So let's name a few more molecules. Carboxylic acids. We did before acetic acid or ethanoic acid. And so let's say ethanoic. Or acetic acid. Okay, now if the functional group is attached to this aromatic ring, this is benzoic acid. And if we have other groups, functional groups attached to the ring, we have to name them as substituents. So say that I have this, and I want to name it, so it is a derivative of benzoic acid. I know that in the priorities in the list, and that we have that the carboxylic acid has higher priority over the phenol. This is a phenol. So now in the ring, I'm going to call this position 1, where the main functional group is attached. And then we're going to say 1, 2, 3, and 4. So this is 4-hydroxy. What is with this? I'm running out of ink. Okay, doing another color yet then. 4-hydroxy and benzoic acid to that name. Or we can say P or para-hydroxy benzoic acid. I could also have other things. So let's say that I add a metal here. Now things are going to change. These change the molecule, right? So it's no longer that name. Let's do another drawing better. I don't want to confuse you. Of course, it's supposed to help you. So let's do another drawing. So I'm going to add now. I'm going to add a metal here, and just for nomenclature, right? Again, I recognize in the molecule, I have a functional group, carboxylic acid, and I have an amino also. So when we have compounds like that, we can choose a couple options. One option, if we say that carboxylic acid, name it as carboxylic acid, and the carboxylic acid has higher priority over an amino. So I'm going to say this is carbon number 1. But now I need to choose what numbering system. Here I did like clockwise, but here it's best if I do it the other way, so counterclockwise, so that I assign the number 2 to the amino, 3 and 4. Now this nomenclature that we did here, para, hydroxy, we can no longer use ortho, meta, or para when we have 3 substituents at aromatic ring. So we need to just use the numbers. So now this is going to be, is still benzoic acid my pairing chain? Right, and always I need to say my substituents are amino and methyl. So I say 2 amino, 4 methyl, because we're going to be listing alphabetically. So 2 amino, 4 methyl benzoic acid. It does the name of that again. No, you cannot use this. We use this here, the number or this letter, because when we have 2 substituents, we can use ortho, meta, and para. Ortho is when the pattern of substitution is 1, 2. Meta is when the 2 substituents relative to each other is 1, 3. And here the pattern is 1, 4. So no longer can use this one here. Okay. So another example of, so we did like with chains, different lengths. So here, assigning carbon number 1 to where the functional group is 1, 2, 3, 4, 5, 6. So this guy is hexanoic. So hexane, drop the termination at this, and then you say acid. Now, another example that I want to do is the following. Now I'm going to have the carboxylic acid in cyclic alkane. So in this case, what parent chain is going to be cyclohexane, and then we're going to add the word carboxylic acid. So let's do this. So cyclo, it is attached to a cyclohexane. Cyclohexane, and I don't have room, so carboxylic acid. Okay, and that's it. That's my carbon 1. Now, if I had constituents, then things will be different. And let's say that I got a chlorine here. And just to make it fun, I'm gonna do this also. We'll have I'm creating chiral sensors. The sensor is chiral because now you can see carboxylic acid is one group. I have an H there. Chain going down is different to that, so 4 different substitutes. And in this carbon, I have a chlorine, I have an H, and then this chain going to the right-hand side. This is different to that. So another chiral sensor. I have 2. So now I added more complexity to the name. It's a cyclohexane carboxylic acid, but now I need to say that in carbon 3, 1, 2, and 3, I have a chlorine. So I'm going to say 3-chloro, 3-chloro, cyclohexane carboxylic acid. But I now have 2 chiral sensors. And so I need to say what are the configurations. So before all that, I'm going to have a parenthesis. And in carbon 1, what is the configuration? In carbon 3, what is the absolute configuration? So assigning priorities here. In carbon 1, highest priority is this functional group. And the lowest is hydrogen. Then I am between these 2 carbons. So this carbon label 2 has higher priority than this carbon, which will be 6. So if you do 1, 2, 3, 4, 5, 6. And so carbon number, it has higher priority because this carbon is attached to a carbon and 2 H's. That will appear to be the same. Well, let's do it more explicitly. Carbon 2 is attached to carbon 3 and 2 H's. Carbon 6 is attached to carbon 5 and 2 H's. So it is a tie. So in the first, say, layer, so we need to move on to the next one. And in the next one, this carbon is attached to a chlorine, then to a carbon, and then to a hydrogen. Whereas this carbon, I'm going in the next layer, is attached to carbon, hydrogen, hydrogen. So clearly, the carbon number 2 has higher priority over carbon number 6. So when I'm doing the priority, then this is number 1. Number 2 is over to this side. Number 3 is to this side. So in the hydrogen is the lowest priority, is in the back. So I can simply do 1, 2, and 3. So that is 1s. Okay, and now the configuration for carbon 3. For carbon 3, I know that I have a lot of lines, so let's erase some of these to make it clearer for the second configuration. So you have that already. And this is just part of the name. Remember that this parenthesis goes this before that. And you're going to have to add a dash here. Okay. So now I am doing the configuration of carbon 3. This is 6, this is 3, 4, That's 5. So if you look at carbon 3, the highest priority is the highest atomic number. When you look at the substituents at carbon 3, my chiral center, so highest priority is chlorine. The lowest is the hydrogen 4. And then I'm between carbon 2 and carbon 4, 2 carbon atoms. So I need to see how they are bonded. Carbon 2 is attached to a carbon, which is 1, hydrogen. Carbon 4 is attached to a carbon and hydrogen, which means it's a tie. So I need to move on to break the tie. And here you see, if I move over here, this carbon 5 is attached to carbon 6 into 2 hydrogens, whereas when I move over here, carbon 1 is attached to a carbon, so carbon, and hydrogen. So clearly, this is the highest priority. So removing a little bit of the mess. I want to, so let's see. I said priority 1 is the chlorine, priority 2 is this, priority 3 is this. Like priority 4, your lowest is in the back. So we can do that directly. I did it on purpose so that we skip that step. So we're gonna go across number 4. So we're gonna do this. So it is R. So the whole name would be 1s3r-3-chloro cyclohexane carboxylic acid.